Welcome back, everybody. In this video, we're going to learn about how to solve systems of nonlinear equations, but it's going to use the techniques from my lecture series on solving systems of linear equations. So if you haven't watched that series, please go and watch it now. Otherwise, let's get started. Nonlinear equations are when I don't just have lines in the system. For example, in this first problem, I'm asking you to solve this system of equations, but notice I've got a line with a parabola, right? So I'm asking you to solve x plus y equals 2 and y equals x squared minus 4 using substitution. Notice that the bottom equation is already set up to substitute. And by the way, nothing changes about these techniques, just because they're nonlinear. So I know y is x squared minus 4. I'm going to sub equation 2 into equation 1. And this gives me a single variable equation in x, right? X plus y, which we see as x squared minus 4, equals 2. It's just that this equation is a quadratic equation, not a linear equation, to solve for x. But luckily, this guy factors nicely. Why don't you pause the video here to see if you can finish this problem off. When I combine all of my like terms, this quadratic equation factors nicely into x plus 3 and x minus 2, so my solutions are negative 3 and 2. But here's where things get slightly different from the linear equation process. Notice I kind of have a fork in the road now. Well, which is it, negative 3 or 2? Well, it turns out it's kind of both, but let's see what happens in either case. So in the negative 3 case, then my bottom equation tells me that y is negative 3 squared minus 4, or 9 minus 4 is 5. If x is 2, then this tells me y is 2 squared minus 4, or 0. So there are two solutions. One of those is negative 3 comma 5. The other one is 2 comma 0. So these together are solutions to the system. But let's see what that looks like in a picture. So you can see here I've got x plus y equals 2 graphed in red, that's the line, and y equals x squared minus 4, the parabola, graphed in blue. And sure enough, there are two places where these two graphs cross each other, at negative 3 comma 5 and at 2 comma 0, just like we found algebraically. Now I've got one for you to try. Go ahead and pause the video here to see if you can tackle this problem on your own. I found 4 solutions to this problem. 1, 3, negative 1, negative 3, 3, 1, and negative 3, negative 1. Feel free to pause the video here to check over my work. Otherwise, I've got one last problem for us to try, because we haven't used elimination yet. Let's solve this system of equations using elimination. Now, we should all be aware that this is an equation of 2 circles. But notice the y variable is almost set up for elimination. If I multiply equation 2 through by negative 1, I'll get x squared plus y squared equals 25. And again, doing that multiplication, I'll get negative x minus 8 squared minus y squared equals minus 41. And now I just need to add those two together. I will get x squared minus x minus 8 squared, and my y variable will get eliminated. The constant term is going to be negative 16. Go ahead and pause the video to see if you can solve this quadratic equation in x on your own. I found that this whole big nasty thing gives me that x should be 3. And now I just need to use that information in one of the equations above. The first equation's a little bit nicer to work with, so I'm going to use that one. I will get 3 squared plus y squared equals 25. Or 9 plus y squared equals 25. That tells me y squared should be 16. So y is plus or minus 4. Hence, the solutions are either 3, 4 or 3, -4. In this video, we saw that we can use substitution and elimination to also solve nonlinear systems of equations. That's going to wrap it up for this video. I'll catch y'all in the next one.